Our next data type isn't visual, but it's still very useful if you're working with sound of any kind. Maybe your model takes in an audio signal or potentially generates one as well. And in both cases, it's useful to hear the samples that you're working with. So let's look at an example of that now. Here we're just going to generate some random noise, a random audio signal. We're going to be sampling from a uniform distribution between -1 and 1. And we're going to create these samples for 1 second. So we're going to create 44,000 samples because we're working with 44,000 hertz audio sample signal. Next, we want to scale our data. So in our case, we've already got it between -1 and 1, but in other cases, you'll want to rescale. So your data is between -1 and 1. And now we have that as an ND array, we can pass it to the summary writer. So after creating the summary writer context, as usual, we call the add audio method. Now we can give a tag as uniform audio, and we provide the ND array containing the audio data through the audio argument. So we're specifying that here. And we specify our global step as well. There's a default argument that's been set in this function, and if we look at the doc string, we can see that sample rate has been set by default. You can change this, and this will update how the audio is played in TensorBoard. But it's set to 44,000 hertz as well, and that's what we've generated, 44,000 samples. So we're going to get 1 second of audio that's been generated and played. So if we generate that and save it to disk, we can move on over to TensorBoard, and we should see an extra tab has appeared. So let's do a refresh. We can now move to the audio tab, and we have a player that's ready for us. So if we play our sample, quite a horrendous noise, but that is our audio sample that's been generated. And you have the options to download as well. So it's downloading as a WAV file.